What's up guys, Shawnthebro here, and today we're going to be going over throws part 2. So, this episode is in particular pretty exciting to me, just because we're going over what we did in throws part 1, but then expanding upon it and making it a lot better. So let's jump to the end result here, where if I throw my opponent, pick them up, throw them, and then, they have to get back up. But damage is dealt when they hit the ground. There is a slightly weird little flip that happens for both characters. And that's because, the characters are trying to flip to face each other. Both of these animations, like the backward throw and then the stand-up animation resulting of that, aren't flipped. So in doing this, they have to kind of flip and turn to each other. Now, if you have just a rotating animation, this will work just fine. You can just flip them during the rotation animation, and you'll see that it actually will look great. And I'm going to be implementing that, but it was just too much for one episode. It might actually need its own episode so I can cover exactly what I want to go over. But yeah, so player 1 and player 2 can obviously do this, but that's the extent of it. So this is how you can do a throw. Of course, my animation might be different from yours, but essentially, we're grabbing the opponent, causing the opponent to enter an animation when we start throwing them, and then we're going to release the opponent and launch the character in a method that makes it look nice, make it look like he's actually being thrown, and then we zoom the camera out, that way we can see, because if we want to really get some distance, we need to be able to see them while we do the throw, otherwise they'll go a little bit off screen, and that's okay. If you don't want to zoom the camera out, then you just don't have to do that one part. It's its own piece. So, lastly, you can see the damage is only dealt on an anim notify when they hit the ground. So yeah, that's how this is going to go. I'm going to show you two methods today. I'm going to show you the original method from throws part 1 that we were using and how you can use that. And then I'm going to show you a method if you have an animation for a character being thrown that we can use here. We're going to need our camera, our animation blueprint of the character we want to perform throws and being thrown on, and we're going to need to make a few variables in code, but not a lot. So guys, before we get started on this, if you'd like to catch up on the throws part of the fighting game tutorial, part 1 is definitely going to be used in this episode, so you're going to want to watch that first. I'll leave a link in the icon in the top right corner right here. That way you can get caught up on that and kind of know. You see I have method 1 and method 2. In part 1, we go over method 1, which is good, but not everyone wants to use method 1. Method 2 is a little bit more advanced, but it's for if you have an animation of a character being thrown. It usually looks a little bit better. And also guys, just in case you're new to the series, this is episode 53, so we are very far along. We have a new episode every Sunday. So if you'd like to catch up on that, then feel free to check out this icon in the top right corner right here. We have to first disable the animation transition in the state machine, and then I also have to hook up the logic of calling the begin throw and end throw grab, which is stuff we did last time. This is not new, but I'm just going to show you the difference. So let's try this again, and here's method 1. If we throw the opponent, you can see it looks okay. We attach them and we throw them, and it can be nice looking. There could definitely be more work done, but it's a little weird, right? When we're attaching to component, you see sometimes, depending on the distance and the side we're on, he kind of moves a little weirdly. And it just does not look optimal. However, if you don't have any animations for being thrown, this method is completely viable. You can definitely mess with the sockets and make this look a lot better. This is still pretty good. It's where we started in episode 1, and for starting with throws, it's not bad. So I won't cover all the logic, but just to kind of recap, what we were doing is we were calling this begin throw function, which essentially attached the one actor's mesh to the other actor's mesh at a certain socket. And then I added some additional logic to freeze and move the camera, which we'll be covering for method 2 anyway, so I'm going to leave it alone for now. Then I went ahead and updated it to where you can use different sockets based on if you're flipped or not. So if you're on the left or right, you can use a different socket. And then I cleared the hitboxes after a short delay just to make sure that the throw hitbox went away early, because it was lingering for a long time. Then on end throw, this function, what I was doing was I was detaching the one mesh from the other mesh and reattaching the other player's capsule component, their mesh to that capsule component, as well as moving the capsule component based on where the throw was going to place them. So this is where I was determining where the player ends up after we're thrown, and then I was reattaching them. Now, that method really is fine, but it's just not great. The thing is, attaching things to sockets in Unreal is good, but it's good when you know you have a specific point you want to attach to, and you have animations to fit that. Without animations, it can look a little bit weird, a little jittery. And like you could see sometimes when I was throwing, he was, moving from the socket just because there's a lot of things going on. It's trying to connect with that animation, which it can't always do, especially if the socket goes inside of something else. It just looks a little bad. There's a lot of clipping. But yeah, if you want to use this method, then the only things you have to add are the freeze camera, resume camera, so freeze camera and begin throw. And then in end throw, I set the character was thrown in the mutant character's other player, because this is the character that is throwing. So in the other character, we throw them. We say we are thrown. And then we resume the camera. Okay, so that's method 1. And I don't want to spend a ton of time on that today because I think you guys are going to really like method 2. But I wanted to show you, it is possible to use it, and again, someone could clean it up much, much better than I could, and you guys can make it look really nice. So I still want to show it, it's still valid. In fact, a lot of throws in games actually work off of this method. However, I prefer, especially in the fighting game sense, if we just have a victim throw animation, essentially, then when the throw box hits, we can play the animation, push the character to where we want by launching them, and then we can actually determine where they should go and when they should collide with things. That means we can send them as a projectile almost, and then when they hit the ground, they can resume their normal life. So let's go ahead and do that. So for one, method 1 has to be disabled, both the begin throw logic and the end throw logic. I'm doing this on grab successful. So this is important. The grab successful anim notify is an anim notify in my state machine. So here's my throw logic. We go idle to start backward throw. This is the attempted grab. See, this is where he's grabbing, and then if I miss, and that's it. However, if I connect, then I go to this backward throw connect. It has landed throw as the Boolean requirement. And it's this. It's the actual throw. It's what we can do after we've connected. Okay? Now, this right here, from the attempted grab to the actual throw, that means if we land that, well, we've successfully grabbed the opponent. So if we have, I go ahead and call the grab successful event on this animation transition. This other thing isn't really necessary. It wasn't in here last time, so you probably won't recognize it. But I made something called backward throw recovery and made it automatic rule based. So once we were done playing this animation, the actual throw animation, we would go to this animation. So backward throw recovery looks like this. It's just the mutant getting up after doing the throw. Because remember, I was talking about how they have to do the weird flip thing to kind of face each other afterward. But it was looking really bad because they were, he was on the ground, crouched, and then he would flip and stand up at the same time, and it was just a lot going on. So I added a nice little get up animation here. You don't have to do anything with him. He's just to make things look nicer. Make sure it's not looping if you do add it. And then one important note about this, if you do add a recovery node, you can make it automatic rule based to go from this straight to idle once he gets up. However, we had an end throw transition event that we were using. Make sure you're still doing that. Just do it on the recovery now as opposed to connect to idle. And in fact, remove the connect to idle animation transition. We no longer want to do that because that basically performs logic to get us back into idle. If we do it early, then you're going to be able to move during your recovery and it's just not going to look good. So I'd say do the recovery and then add the end throw transition. Okay, I'm intentionally leaving this in here. This is method 1 and 2. Method 1 consists of 3 nodes. Method 2 actually only consists of 1 node. That's another beauty of method 2. But let's cover them both because this will be pretty quick. So basically, all we have to do to go through these states are to determine if the player has been thrown. Now, an easy way to do that is I made a state for grappled, thrown, and throw recovery. And the animation transition I have for idle to grappled is just if the other player has landed to throw. Remember, the state machine is working for this one character. Like if we have 2 mutants, it's only working for 1 mutant at a time. There's 2 state machines, 1 for each mutant. So, if the other player has landed a throw and there's only 2 players, well then guess what? I'm the one that needs to be grappled. Okay. So, if we're grappled, then I have this static animation, which I was putting as the state to go to. This is kind of like his grappled look. Nothing fancy, just to say, hey, I have been grappled. Then all I do from there is you can loop it or not. For me, it doesn't matter because it's a 0 frame animation. But then grappled the thrown goes. I'm having it go off the logic was thrown. It's a boolean that I've added. Now, was thrown isn't really set anywhere else except for in method 1. It was thrown in the end. It was called in the end throw function. This is why I was setting this here. I was saying once the end throw function is done, we go ahead and set was thrown, which makes sense. And just for the record, if you want to see was thrown, it's just a boolean was thrown. Very simple. Make sure you set it to be false by default in the constructor. And lastly, I had this throw recovery, which just automatically from throw goes into throw recovery. And throw recovery just looks like this. Just the mutant getting up. And then it returns the idle. Throw recovery to idle, which is automatic. Once the character has recovered, they can just return straight to idle. Now, that's good, but you see already how this is a lot of steps. Not like it's a huge deal, but that's all for method 1. Method 2 is going to be a lot more convenient. So for method 2, we're going to have one animation that essentially takes care of all of that, and we can just play it. And we can line it up so that it looks better, but we can just play it and it's that simple. So make a new state. Right click and add state. I called it grapple through thrown. We still have to do throw recovery separate because that wasn't part of the animation. I mixed 2 animations together. So if we have, I have to reset this up because I disconnected it for showing off method 1. But we check and make sure that we've landed throw. So if the other player has landed a throw, then we know that this player should be getting grappled and thrown. I'm going to go ahead and disable, or better yet, if you want to keep 2 methods in and not have a warning, you can go ahead and do this. Because if you take out the transition rule here, the boolean that goes into this result node, then you'll actually get a warning saying that, oh, this node will never be taken. And it's kind of annoying to see a warning the whole time, especially when I'm doing the tutorial. I want to leave some things in that aren't necessarily, everything, because I like to show different methods of doing things. If you ever need to do that, you can just add an and node, and not check, you can check this box if you don't put anything into it, but don't check it. That'll mean it's always going to be false. It'll never be taken. But then the game knows that there is the possibility of it being taken if this were to get set to true, so then you won't get a warning. Okay, so, but in our grappled to thrown state that we added, we need to make sure the other player has landed a throw. If they have, then we can go into this state. Now to go into this state, let me show you what it looks like. Whoops. So this is my animation. This is right off Mixamo. It's basically there's an aggressor and a victim throw animation. And it's essentially the grappled. You can see him get grabbed. He like gets pulled forward and his arm leans out. And then he's tossed over his shoulder. And onto his back, which our getting up animation that we have in the throw recovery is getting up from his back, which will go ahead and, you know, make this look right. If you have him flipping on his back and then he stands up like, you know, like he's doing push-ups, that's not going to look good. In this animation, we have this apply throw force, apply throw damage, and move collider to mesh. So we've got quite a few things going on. So first of all, I have this apply throw force and notify. You can go ahead and right click anywhere on this graph and add a new notify. The reason I have two like lines here, you can add tracks as many as you want. They're kind of just in there so that you can organize it a bit better in case you have a lot of anim notifies. You can see here these would have overlapped, which you actually can have. As long as the red parts have their own individual timestamp, you're okay. In fact, I'm pretty sure they can even connect, but I know sometimes they'll try and push each other out of the way. You can have these over top of each other, but you can see it's going to look like that, and then you can't read. So what you do is you go ahead and have these anim notifies. You can plus to add a track, and then you can put them in different locations where you can read everything. All right, so I have this apply throw force anim notify, and this apply throw force is essentially where we're going to launch the character. So the animation itself, I'll go through and play it again. The character does not get thrown very far. In fact, when I was actually trying to play this animation the first time, it wasn't even getting over the other mutant, and they weren't even flipping sides. So that's not exactly what we want. We need to apply some sort of force. So I'm actually going to have this anim notify apply throw force to launch the character. We're literally going to call our LaunchCharacter function and give him a little bit of boost. Then, when he hits the ground, now yes, this is an animation, so technically, if you don't time it correctly, then he doesn't have to hit the ground at this part in the animation. And thus, this might look a little bit weird where he kind of bounces. If you have different heights and you want to play this animation, then you can go ahead and split up the throne, like this, the grappled and thrown, and keep him in some sort of loop state right around here. And then when he hits the ground, perform this logic. For the record, anytime you're doing a regular throw or backward throw like we're doing here, I don't think your height will really vary. If you're doing a combo into, you know, landing on the ground, that's different, and we will be covering that in the next air combat episode. But specifically for throws, if you need to break it up, that's where I'd do it. Then I have an anim notify called apply throw damage, which again is just right around where we collide with the ground. So you could do it anywhere in there. I just did it right at the start when he first hits. And then I have this last one called move collider to mesh. So the way we're going to make this work is we're going to throw the mutant. And of course, we can't really throw the collider with the mutant and make it look super nice, because if we do, the collider is going to collide with us as we're throwing it, and if it collides with us, then it won't be able to get over top of us. So this move collider to mesh thing, we're actually going to essentially disable collision from pawn to pawn. That way they can go through us as we throw them, and then we're going to re-enable the collision from pawn to pawn on the capsule collider and to the mesh that we have, so that the pawns can interact with each other. The pawns are just our mutants in this case, but any pawn in Unreal is my point. Okay, so once you set up some anim notifies and you have an animation that's split up like this, where you have grapple, throw, and land, then you're pretty much done as far as that goes. I still have it go into recovery state because I don't have a recovery in that animation, but I do have the throw recovery state we went over earlier, and that does work. So it goes into throw recovery, which remember is this. So once he's on the ground, he's going to get up. Simple as that. Not looping. And then it returns to idle. Returns to idle automatically, automatic rule based. So once this animation is done, he'll go back to idle. Now, a quick little note. I use this to smooth things out. You can use these blend settings and change the duration to determine how long it takes from one state to go to another. Now, in a fighting game, you want it to be quick. You don't want it to be slow because you want the animations to be fast. I keep them a little bit on the slower side so we can tell what's going on and it's easier to debug toward the end of the game and all of that when we're doing testing with it. Then I'll go ahead and speed things up so that we can play around with that and see how it feels. But for something like this, where it doesn't necessarily look all that great to go from my throw recovery to idle, I can increase my duration to make it a little bit better. Make it look a little bit nicer. So feel free to play around with these blend settings durations and make them look nice. I think I did some for the throws as well. Yep. Because normally they're like a 0.2. So I made a few of them 0.4 and just doubled it and made it look a lot nicer. Now let's go into all the logic that method 2 has. We've got our state machine set up. So we essentially have to get all of this working. So we go ahead and take our anim notify grab successful, which we were already using in method 1, but we connect it to new logic. I have it connecting to this method 2 matching animations block. And this is all the stuff for method 2. Now, I'm going to add a few things here. We're going to add one more boolean to the code, and it's going to be called canFlip. CanFlip refers to if the player should be able to flip based off of the tick check to determine if the character should rotate or not. If they should invert their mesh. I do have a few other things in here that I'm probably not going to cover right now just so it's not confusing. But there is a method to just rotate the character as opposed to flipping their mesh if you want the character's backs to be to it and things like that. It would be a lot more accurate in real life. However, I know a lot of times that's not the look that people go for. You can feel free to switch between the two or try them out. If you want to do it, feel free to look at this comment and copy it, but I'm not going to be covering it right now. So don't worry, the logic that is flipping is the same as it always has been in this series. Okay, but this logic and tick that determines, hey, can we flip, should we flip the character's mesh? Well, if we flip the character's mesh, then the problem with that is if we're throwing them backward, we're going to flip, mid-animation, because they're being thrown over our head. So that's not going to look good. We don't want to be halfway through our throw animation, and then we change directions, and then the character is still going the other direction. The thrown character is still going that other direction. That just doesn't make a whole lot of sense. So instead what we're going to do, we already were checking if we were jumping to make sure we can't flip, which is nice. When you're jumping, you don't want to flip in the air and just automatically face the other direction. You should wait until you land. But we also need a more generic time to set canFlip. So not just for throws, but anything else down the line, we'll probably go ahead and just use this canFlip boolean. So, as you can imagine, add a canFlip boolean. If you go into your code, you need to make sure that it's true by default. We should be able to flip by default. Then, in tick, where we're checking if the character is not jumping before proceeding, make sure that the character also can flip. And that's all we're doing in the code. But we will be setting the canFlip boolean in the MVP, so that is important that you do that. So, now, remember, this anim notify is grab successful. So if the throw hitbox has collided, we now want to perform the throw logic. The mutant character reference, other player, canFlip is set to false. Essentially, we have grabbed the other player, so the other player should not be able to flip at this point. Then I do a delay of 0.2 seconds and clear the hitboxes. It's not necessary that you do this, but it is useful. The thing is, if you don't delay before clearing the hitboxes, if you're actually using the hitboxes as like a debugging tool or just a tool, you know, obviously to visualize them so you can see what the range is, if you clear them right away when you're doing the throw, you're not going to really get to see it, because if you're standing right next to the player, the grab throw box is going to go away almost instantly. So I add a little delay so we can see it at all times, but that's up to you if you want to do it. Regardless, you do need to clear the hitbox, because if you don't force clearing hitboxes on a successful grab, it can linger for a long time with the way we set it up. So either clear the hitboxes or trigger the event that normally does, which is like reset variable, or I think it's called, yeah, there's an anim notify that's clear hitboxes. And then after that, I also set that the actual player throwing the other mutant has not landed the throw. Remember, has landed throw is how we get from one state to another, specifically in idle to grappled thrown. That's our transition rule. So we make sure we reset that because we don't want them to continuously throw the enemy if they're within range. Like, we need to make sure that that's false so we don't continue playing that animation. And then I do a little bit of logic here to freeze and resume camera. I told you I would tell you about that later, so let's go into that now. If you go into your default camera, this is the camera that you use for your game, not your special camera or anything like that. We're doing a little camera effect. I'll go ahead and play again for you just so you can see it here. So the camera effect we're doing, if we go ahead and play this. I'm just doing the default map right now because I'm doing some renovations with the maps, so I don't want to go into them because they're a little bit broken at the moment. But alright, so as I throw the enemy player, you can see that the camera actually zooms out, pans out, and then zooms back in, and it's a nice blend. This is because when we were doing the throw, remember it was kind of snapping? You don't have to do this like zoom out, zoom in effect. You can still do it without that and fix the snapping, but I thought this was a good method to it, and it gives us the ability to see where our player is getting thrown. So at least you'll probably want to do this part of it, where we spawn another camera, set the field of view to, you could either do the current field of view or a forced field of view, and then we go ahead and set that as the camera we're looking through. So let me explain what we're doing here. The default camera is always, and I mean always because it's on tick, looking for the actors and then moving with them so that it can be in the center. Now, this is good. Okay, we want to do that. However, in a case like the throw, we actually have root motion on our animation, on our throw animation, which you can see as we play it here. This is root motion. I know we're launching the character to get more distance, but you can see clearly that the mutant is actually moving in this. Well, because of that, the capsule collider is not going to stay with it. And that's perfectly fine, because we're going to be moving it at the end of this. And since, you know, if we do any sort of interruptions mid-throw, that's a different thing. But otherwise, you're not going to need to be able to deal damage on this throw other than the throw itself. In doing that, the mesh is going to be a little bit different from the capsule collider. And surprisingly, the player 1 and player 2 reference doesn't just go off the mesh. It actually, from my knowledge, it looks like it goes right off of the capsule collider, or at least some sort of median. So you're going to not get, it's not going to look all that great. What we can do is spawn a super camera, which if you haven't been following the series, I'll go ahead and leave a link in the iCard in the top right corner right now for super cameras. They're essentially just special cameras you can place anywhere in the scene and do what you want with, and then switch between that camera and our view that we've got now. We can switch between the super camera and the default camera. So we need to spawn one. We need to get our actor transform of this camera, the default camera. Drag that in as the spawn transform. So the way you do this, you spawn actor from class, and then you get actor transform, just as it's spelled there. If I could spell it, right here. And then you can drag this into the spawn transform, and then select your class. Mine's going to be super camera. And that's how I get this node. Now, we go ahead and I set the field of view because if we switch to a camera that has a different field of view, it can look bad. In this case, I actually am not using my current field of view variable, but you could. There's nothing wrong with it. The reason I actually like the kind of zoom out effect. So if you don't like the zoom out effect, then just go ahead and drag current field of view into this. Current field of view is just something on tick. Our current field of view is being set based off of the distance between the characters. And I was just dragging this clamp value right into set field of view. I went ahead and made a variable. You can drag off of this, promote to variable, call it current field of view, and then continue about your day. This current field of view variable can be used here if you don't like the zoom in, zoom out effect. So that's how you can get rid of that. But if you like it, go ahead and just pick an arbitrary field of view that you like. Just be careful that it's not too big or too small. That way you can see everything you need to see, and it doesn't like show you things off the map that you wouldn't normally be able to see. Then I go ahead and save a reference to the super camera. Again, you can just drag off of it and promote to variable. I call it temp camera. And not just temp like if, for those that are familiar with code, oh, temp variable. I literally call it temp camera because we're going to destroy it afterward. You could also just make one at the start and then go ahead and use that reference. I actually go ahead and create one every time we call freeze camera and destroy it every time we call resume camera. It's up to you if you want to do that or not. I just did it because I like to show you the different uses of the super camera. I'm a big fan of the super camera. So what you're going to want to do is add 2 custom events. Just right click, add custom event. Do that twice, call one freeze camera, one resume camera. Okay, and lastly, after we've set our variable, set the field of view, now we want to change to that view target. We want to essentially look through that camera. Remember, the reason we're doing this is the default camera at this point would be moving around, and it's going to look ugly. But if we switch to a different camera in the exact same spot as we already are in, you're not going to notice a transition, and then we can blend to the old camera to make it pan over nice and easy. So go ahead and get player controller 0. Because remember, we're not doing multiplayer, so we're not going to update these get player controller 0s until that point. Because the way we have to do that is going to be a little bit different. And use that as the target. So you can drag off of it and set view target with blend. And then you need to pass in what you're setting. And we want to attach the super camera. You can also use the temp camera here. Like I have the variable reference either way. But just make sure that you set that as a new view target. I set the blend time to 0.4 because I thought that looked nice, but this is the same thing like with the animations I showed you earlier. You're going to want to put a time in here so that it doesn't just snap over there. Okay, and then that's done. We're essentially using our super camera now and not looking through the default camera. But of course we need to return to the default camera at some point. So once we call the resume camera event, we're going to get player controller 0, set view target with blend, but the new view target is going to be self. We're in the default camera. So it's going to be our default camera in our scene. Blend time again, make sure you give it something. I gave it 0.3. Then I made a delay of the same time of the blend time and then destroyed the actor. If you destroy it too soon, it won't actually give you issues, but it will force you to switch to this view target before the blend is done, which we don't want. I mean, that's the whole point of using the blend is we want to be able to see it. So I just did a delay of the same time. To be extra safe, you should probably put it to like 0.4. Just a little bit of extra additional time, but it should work just like this. And then take our temp camera, the variable that we made, and just destroy it to free up that space. We're not going to be using it again. Okay. Let's go back into our mutant anim BP. And that's the first section done here for matching animations. The only other thing that we have to do is deal with the 3 anim notifies that we have on that animation right here. We have to perform the logic for all 3 of them. We need move collider to mesh, apply throw force, and apply throw damage. Let's just do them in order. So apply throw force is, remember, where we're launching the character and disabling collision with the throwing character. That way the character can actually be thrown to the other side. To get any of these anim notifies, all you have to do is type in their name, right click, apply, throw force, just like this, and you saw damage. Just click the one that you want. Make sure you get all 3 of them. And here's something cool we can do that we haven't done yet in this series. You can actually set collision responses. And like in the hitbox, it's just overlap all, right? And in the capsule component, it's just block all. We can actually set collision responses to specific channels, and we're going to use that right here. So in this case, what we want to do is apply throw force. This is the character that is getting thrown. So if the anim notify is firing, we don't need to grab other player. We just need to get mutant character reference. We need to get their capsule component, and we need to set their collision response to channel. I can go ahead and do this for you, but it's pretty much as easy as it seems. Get your character reference, get capsule component. This isn't something I added. This is just basic to characters. Get your capsule component. And then you can drag off your capsule component and set collision response to channel. Not to all channels, because if you throw them and they have no collision, then he'll fall through the floor or go through the wall or something like that. You have to make sure we're only disabling it for other pawns. So to channel, and then in your options here, channel is pawn, and then new response, ignore. This way we can fly through, the thrown character can fly through the throwing character. Then I go ahead and check if the character is flipped or not, and then launch them the corresponding direction. Now this might take some little bit of playing around with. I actually put 600 right at the start, 600 and 400, so both horizontal and vertical distance. I put these values in right at the start and was like, wow, that actually looks pretty good. So I just left it alone. But you may need to play around with it to make it look the way you want it to. Or maybe get the timing right on the animation, like when he collides with the ground and things like that. But we're literally going to be launching the character. I mean, I can show you. Without doing this, without doing the launch, you can actually see what the animation looks like without the launch. So it still does everything we normally do. It still works. But see how it's not quite right? Like there's a little bit of teleport because it's trying to move the capsule collider to that position. And also we're right over top of the character. Like it just doesn't look good. So applying a little bit of launch really smooths that out. So that's how you do this. You just literally grab your mutant character reference after you check if they're flipped, then drag off of it and call launch character. And just give it your velocities. Again, you might have to play around with it, but it should work just fine. Let's go to move collider to mesh next. So I have this function called end unattached throw. Now if you watch throws part 1, you have this end throw function, even if you're not using method 1 and you're using method 2, which is the main point of this episode. You'll still have this end throw function. So you can go ahead and duplicate that, right click, duplicate it, and call it end unattached throw, or whatever makes you know that this is the throw where we're not attaching to component. So you can get rid of everything that's in end throw in this end unattached throw function that doesn't have, or that has to do with attaching or detaching. So let's go to end throw. We have detach from component and attach to component, but we don't need either of those. We also don't need this was thrown boolean if you did add that earlier, because we're not using the was thrown logic in method 2. Okay, so once you remove the detach from component, you can also remove the mesh reference that was right here. You remove the attach to component, and you can remove the was thrown boolean check. The rest should be the same. I did not adjust it to make it look neater because I was trying to show you that it's the same function. That way I don't have to cover this whole thing again. You guys have seen it. Just remove those things. But otherwise, we do have to make sure we have this resume camera node, end unattached throw. Because end unattached throw is happening on move collider to mesh. Now remember that this function actually takes in a float, which is your distance that the character is going to be thrown. So I can make it bigger or smaller. Just make it where it matches up with your animation once you have the force in place that you like. I put 220 because once I put 220 after launching the character like this, it did not appear like any teleporting was going on, which is what I wanted. I did not want it to look like things were jumping around. And once we're done with the throw though, and they're on the ground, we need to also make sure that the capsule collider can now block and interact with the pawn again. That way they can collide. So the way we do that is we grab our mutant character reference and grab our capsule component, just like we did to set the collision response to channel. And we're going to call set collision response to channel again, but this time the new response is going to be block. So pawn and ignore when you're trying to make the one pawn not be able to hit the other, but pawn and block when you want to go back to normal, because that's how it is by default. So just use pawn as the channel and block as the response. And this means that once the character can get up again, their capsule collider will be there, so we'll be able to collide. You won't just be able to walk over them. You'll still be able to jump over them and all, but you won't be able to just walk over them. Okay, and then lastly we need to apply our damage when the character hits that and notify to apply damage. It's quite simple. We've actually done this before. So sure, we do logic to check for hitboxes to take damage and stuff, but we can also just call take damage. So anytime we want to call it at a specific point, all you have to do, grab your mutant character reference and drag off of it, call take damage. There you go. Then you give it your value. I did 20%. You can keep everything else at 0. And you are good to go. That is method 2. There are a few things you should do before we wrap up here. If you are using method 2, you have to make sure that the can flip boolean is being reset properly. We set them to not be able to flip once they're getting thrown, but we never set it back to true. Well, not yet. So what we have to do is in our clear hitboxes function, you can do it, which is kind of a weird spot and is making it to where in our anim notifies where all the attack ends and things like that is one place you could set the can flip to be true. Now it's kind of a weird spot to do it in my opinion, just because it doesn't seem to match up with the rest of the logic, but at second look it actually does. When you take a second look at this, it actually does, because when we can move again, we can flip again in this case. You see that? And basically, that's essentially true. If we're not jumping and we can move, we wouldn't be able to move if we were throwing or being thrown. So if we can move again and we're not jumping, so if we can move again, then we can flip again. And it's honestly quite that simple. It'll depend on your game. You might have to change where you put it. But adding it here should be perfectly fine. I also went ahead and added it to reset variables at the very end, which, if you're not familiar with this function of the series, that's actually okay. You don't really need this. But essentially I have a function to where I reset everything to default, just in case anything is to get stuck or we're going to forget the logic. The game actually picks up on it on its own, you know, once a certain notify has been reached, like at the end of an animation or on idle. And then we just go ahead and set can flip to be true. Just in case anything goes wrong and I forget it, it should still fix itself. Just a little safeguard there. The very last thing that I do, and this is important still. So we are setting the other player, the player that's getting thrown, to not be able to flip, but we also need to be able to set the player that is throwing to not be able to flip during this animation, because that also won't look good. I have this start throw grab, which is an anim notify that we had in part 1, but I'll go ahead and show you where that's at. And I just set the character that is doing the start throw to not be able to flip as well. And that should fix all your issues with all the flipping and things like that. So the start throw grab anim notify is on my actual throwing animation, not my grab animation, which is, you know, makes this name a little bit confusing. So that's on me. And the main reason is because I actually changed around the animations I was using quite a lot. So this was intended to not be what it is now. And I put the anim notifies in before. But yeah, my backward throw is this, or my grab attempt is this. It's not on my grab attempt, it's when I actually start the throw. That's my start throw grab anim notify. One other thing about that, and just to make it a little bit easier for you guys, that animation is my backward throw connect state in my state machine. That should help you piece it together. That's when I make it to where the attacker cannot flip. Okay, so this has been one heck of an episode, and I know it's a little messy with the Method 1 stuff, but I just wanted to show you it is still actually very viable to use Method 1. I obviously tailored to Method 2 in this episode because I really like the way that Method 2 looks and feels, and honestly it's easier to implement it more cleanly. But I did want to show both methods. I mean, like I said, there are games that do this method. It's just usually you have to have more control over the skeleton and over like animation blends to make this one work and look nicely. But if you don't have that, then you can go ahead and just use this as long as you have an animation that works for actually being thrown with root motion and things like that. If it doesn't have root motion, it's actually still okay. You can still use the launch character to make it work completely without root motion. So, no worries there. Alright guys, well thank you so much for watching this episode. If you enjoyed, please subscribe. It does more for the channel than anything else you can do, and I just really appreciate it. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord. We'll be happy to help you out with any of the issues you had there. I'd like to give a huge shout out to my YouTube membership subscribers and Patreon supporters. Thank you guys so much for all the support you've given and for continuing to believe in me and support me throughout this series. I mean, I'm really excited. This series continues to get better and better, and I'm making little things every time neater. Like, the character's feet are now on the ground because I moved them down, and that's like a 5-second change, but it can make all the difference. It just makes it look a lot nicer. But I'm just very excited for where this series is going. We have a few more topics I want to get into before we get into things like AI, but it's coming pretty darn soon, I will say. So thank you guys so much. And if you want to support me on Twitch, twitch.tv/Shawnthebro27. We play Demon Souls, and I'm doing a different horror game every Friday with my friend David, MalthaelsMight. Anyway, guys, thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.